Hi everyone, welcome to today's lesson in mathematics, and in this lesson we'll be looking at place value and expanded numbers. Place value and expanded numbers. Last week we looked at numbers like identifying and writing numbers from 1 to 1000. Identifying and writing numbers from 1 to 1000. And in exploring that, we kind of touched on place value and how that helps us to accurately name numbers and write numbers. We touched on that, but it wasn't really in details. It was just the aspect of it that would help us to name and identify numbers. So today we're actually going to look at place value itself, and we'll be considering numbers up to hundreds of thousands and even a million. That's the unit of million. Okay, and then we look at the expanded form of these numbers. So to begin our lesson, we're going to look at this place value chart that we have here. We explore this place value chart and we see how it helps us to accurately place digits in numbers in their correct positions, okay, which helps us to determine their values. Remember, we said that place values actually refers to the value a digit has, okay, the value a digit has when is combined with other digits in a number based on the position it occupies. The value that a digit has based on the position it occupies in a number. We gave an example of number like 2 and 6, all right? So we had the first number as 26 and the second one 62. So looking at the two numbers, we saw that these same two digits, in two different numbers assumed different values. Why? Because their positions changed. In 26, 6 occupies the position of units and the value is simply 6 units, while the unit occupies the position of tens and the value is 20. But in 62, we find the 2 in the position of units now having the value of just 2 units, while the 6, now occupying the position of tens, has the value of 60. So we just used that in our previous lesson. We used it as an example to help us see how the position of digits in numbers can affect their value. Okay, and that's what basically place value is all about. It's about the value that a digit has based on the position it occupies in a number. Okay, so today we're going to look at this place value chart, and what we have here before us is from unit to million. Okay, this is a basic place value chart. So here you have the units. Sorry, there's an S there. So to a far right end, you have units, and then working towards the left, the next position is tens. And the next one is hundreds, followed by thousands, tens of thousands, hundreds of thousands, and then we have million. Okay, we're going to stop at million in our lesson for this grade level. So you have units, you have tens, you have hundreds, thousands, tens of thousands, hundreds of thousands, and million. Now, I would like to mention here that the units in this place value for whole numbers, because what we're dealing with here is whole numbers. We're not dealing with fractions. We're not dealing with decimals. So for whole numbers, the units occupies the position that has the least value. The unit position has the smallest value. Okay, and as it goes or moves towards the left, every point increases by a multiple of 10. Every point increases by times 10. That is how it keeps increasing until you get to the last point. So you find out that, for instance, this is unit. by the time you step to the next level to the left, it is whatever number is there multiplied by 10. When you go to 100, it's whatever number is there multiplied by 100. The next one multiplied by 1,000. And if you look at each of them, 10 has 1 0, 100 has 2 zeros, 1,000 has 3 zeros, tens of thousands or 10,000 has 4 zeros, 100,000 has 5 zeros, and a million has 6 zeros. So you just find out that as it keeps moving by each step, the multiples of 10 keeps increasing by multiples of 10. You keep multiplying by multiple of 10, to the next level. So here are the symbols or the letters that are used to show these different positions. So here is units, is represented by U, tens by T, hundreds H, thousands by TH, tens of thousands by TTH, hundreds of thousands HTH, and million is M. Now when you are working with numbers and you come across this, you shouldn't be confused. That's why we are trying to bring this up so that you understand what this is all about. I know you are used to or familiar with UTH, unit, tens, hundred, okay, and probably TH, which is thousand. But I know that TTH, HTH, and M is a kind of, maybe at this level, is not so familiar. So the T here is tens of thousand, the H hundreds of thousand, and the M is million. Okay, here we have a number we have written and spread out under these positions. We're going to look at this number later, and we actually see what this number is, what value each digit has, and what place value each digit also has. We're going to see how place value it kind of differs from the value of a digit. The place value of a digit differs from the value of that digit, and then we're going to also see how this whole chart will help us or can help us in naming numbers. We're going to see how that helps us. Now let's take a closer look at this place value chart and the number we have here, for an example. So if you look at this unit position, you have the number 3 there. In the tens position, you have the number or the digit 6. In the hundreds position, you have the digit 5. In the thousand position, 8. Tens of thousand, 4. Hundreds of thousand, 3. And in the position of million, you have 1. Okay, now we are going to first look at the place values of these different digits. First their place values and then their individual values, okay? And from there we take it on to how they are expanded. Okay, actually in looking at the individual values of these digits, we are actually entering the expanded form of these numbers, okay? By the time we expand them, you will see that expanding them actually takes us to the actual value of each digit. Okay, so but first let's see the positions these different digits occupy. So for the first one here, 1 is in the position of million. Okay, 1 is in the position of million. So you have 1 million. The 3 is in the position of hundreds of thousands. You call it 100,000s or hundreds of thousands. So 3 is in the position of 100,000, so it is 300,000. 300,000. Then 4 is in the position of tens of thousands. Okay, so you say 4 10,000s. 4 10,000s. 8,000. 500. 6 tens. 3 units. 1,000,000. 300,000. 4 10,000s. 8,000s. 500s. 6 tens, and 3 units. Now, those names of the positions we're calling is actually the place value. If they ask you, for instance, what is the place value of 3? Okay, since here you have that 3 is 300,000, you will simply say that the place value of 3 in this number is hundreds of thousands or 100,000s. Okay, if you are asked for the place value of 1 in this number, in this number is million. Place value of 5 is hundreds. The place value of 6 is tens. Okay, so that's what we basically wrote out here. 1,300,000, 4 10,000s, 8,000s, 500, 6 tens, and 3 units. So please, you need to just try and get used to these different positions. Okay, so when you're asked for the place value, just look at, that's why it's important, like I always say, it's important for you to get a hang of this place value chart. Is very, very important, because it's going to help you a lot in working with numbers, you know, both from identifying numbers, naming, writing, and stuff like that. You know, an understanding of this place value chart will really help you to be a master in handling your numbers. So once again, let's go through it from the left, from the right towards the left. We have units, tens, hundreds, thousands, tens of thousands, hundreds of thousands, and million. Now, tens of thousands can also be 10,000s. Hundreds of thousands can also be 100,000s. And then you have your million. So this is one way of representing these numbers. Okay, we have several ways of representing numbers. We are quickly going to take a look at them. Okay, we're taking a look at them, although our focus is on place value and expanded numbers. So this that you see now is one way of representing these numbers. Okay, next I'm going to show you how you expand this number. Okay, I'll just show you how you write the expanded form of a number like this, and then we'll go on to how you name this number, or how you name it, and subsequently how you write it out. So for the expanded form of this number, it's very simple. For 1, for instance, you write out your 1. The expanded form will be that every other digit after this 1 becomes 0. You write your 1, and then every other digit after this 1 or 2, the right of this number or this digit becomes 0. So this one, as you see, it is 1, 2, 3. Remember, we are putting our commas, 1, 2, 3 after every 3 points. And we are also going to explain why we put our commas after every 3 digits. Okay, so the next digit we have here is 3. So for your 3, this is where your 3 occupies, so you write it there. It would be wrong if you bring your 3 and write it under 1. They don't have the same value. Okay, they occupy different place positional and numerical positional values. They occupy different positions, so you can't write them. You see this 3, you put it where it ought to be, right here, because it's one step towards the right of the million position. So you write it down there, and then every other digit after 3 becomes 0, just like in the case of the million. So 1, 2, 3, you have your comma. Now you can't place comma anywhere because the remaining digits are just 3. So we have settled that. The next digit is 4. So 4 comes right where it should be, a step towards the right of the digit 3. And then every other digit after 4 becomes 0. And again, after counting 3 from the right towards the left, you place your comma. Okay. Now the next digit is 8. You place it where it should be. Okay. Every other digit again becomes 0. So you have 1, 2, 3. Remember your comma. The next digit is 5. 0, 0. right? No comma can be used here because there are only 3 digits. And the next one is 6, and the only digit after it becomes 0. And lastly, your 3 comes right there. There's no number after, no digit after the 3, so that's your 3. I hope it's clear. So this is how you expand this number. You ask for the expanded form of this number, that's what you have right there. Okay, so 1, once you bring out the digit, as you are dealing with them one after the other, what you just do is take the first digit, start from there. Every other digit to the right of that digit becomes 0. When you're done with that, you go to the next digit. You write it out. Every other digit to the right of it becomes 0. That's how you do till you get to the last digit, which is in the unit position, and that's the only digit that does not carry a 0 after it, because it has no digit coming after it that is going to become a 0. So this is the expanded form. But the commonest way that you will find this expanded form represented is what we're going to write out for you now. Okay, we're going to show you the commonest way that this expanded form is not. Now this is the commonest way that you find expanded numbers being represented. This is the commonest way. So you remember how we spread out 1, and then every other digit to the right of it became 0. Now if you count the digits to the right of this 1, there's 1, 2, 3, 4, 5, 6. That means this one is supposed to have 6 zeros after it. So you have here 1, 2, 3, 4, 5, 6. Now you go to the next number 3. So you put a plus sign and you write your 3 out. After writing that 3, every other digit to the right of 3 becomes 0. So let's see how many digits we have to the right of 6. Right of 3, you have 1, 2, 3, 4, 5. That means this 3 should have 5 zeros after it. So you have 1, 2, 3, 4, 5. Okay? Then after 3, the next digit is 4. That's the 4 over there. So you write plus 4. Then to determine how many number of zeros, the number of zeros you're going to write, just count how many digits are after your 4. So you have 1, 2, 3, 4. That means this 4 should have 4 zeros in front of it. After which you write your plus. The next digit is 8. That's it. You have 1, 2, 3. So there should be 3 zeros. 1, 2, 3. You write it. Plus, the next digit is 5. And that's the 5 you have there. How many digits after 5? Just 1, 2. So you have 2 zeros. 1, 2. The next digit is 6. After 6, you have just 1 digit, which is 3 in the position of units. Only 1 digit. So you write your 6. And since there's just 1 digit after it, you write 1 0. And lastly, you have your 3, which is in the position of unit. It has no digit after it, so you just write your 3. You can't add any 0 this time because there is no digit coming after the 3. So this is the commonest way that you find expanded numbers being represented. Now, I'd like for you to know that there are cases or instances where you will be given expanded numbers and be asked what that number is in the standard form. Okay? You could be asked what that number represents or stands for in the standard form. Now, before we go on and just see the different ways that numbers can be represented in, let's quickly take a look at this one once again and see if we can name this number. Or first, let's talk about the value of each of the digits. Remember, we talked about the positional value or the place value. When we said this is in the position of million, we called it 1 million. This is in the position of 100,000. So the place value is 100,000 of these 3. Place value of 4 is tens of thousands. The place value of 8 is 1,000. But then when you are asked for the value of the digits itself, for instance, if somebody asks you what is the value of 8 in this number, remember, I didn't say place value, I said value. So the value of 8 in this number is 8,000. That's what you see there. You can write it this way, or you can write it out like 8 as a number, and then your thousands could be in words. 8,000. You're correct. Whether you write it like this or you write it this way is the same thing. So this is the value of the number, the digit 8. If you are asked what is the value of the digit 4 in this number, the value is 40. 40,000. You can write it like this, or you simply write it out the way it is right here on the board. 40 and then your 3 zeros, which places it in the family of 1,000. So this is 40. Why 40? Why do I say 40? Now don't get confused. Remember that this number, the digit rather, is in the position of 10,000. 10,000. So this number is in position of tens of thousands. So it's 4 10,000s. 4 10,000s or 4 tens of thousands. Now what is 4 tens? We know that tens, any number in the position of tens always has a 0 attached to it. Any number in the position of tens always has a 0 attached to it. For instance, the 6 here in the position of tens is 60, 6 and 0, because it's in the position of tens. So this 4 in the position of tens of thousands, first we have its 0 attached to it to make it a number in the tens position. And in addition to that, because it's in the position of thousands, it will also have 3 digits added to it, because 3 zeros is always what makes a number to be placed in the family of thousands. Whenever it is thousands, there must be 3 digits or 3 zeros after that number. So the 4 tens indicates it is 40, and then the 1,000 is for the 3 zeros. So the value of this number is 40,000. 40. So looking at these individual numbers as they have been written in the expanded forms, they basically tell us the values of each of the digits. They basically tell us the value that each of these digits has. Like this one now is 1 million with 6 zeros. The 3 is 300,000. The 4 is 40,000. The 8 is 8,000. The 5 is 500. The 6 is 60, and the 3 is 3. So these are the values of these digits in this number. But when you talk of the place value, you now mention the positions they occupy. Whenever they ask for place value, you mention the position they occupy. For instance, the place value of this 4 is 4 10,000. It's 10,000s rather, or tens of thousands. The place value of 5 here is hundreds. That's the place value, is hundreds. The place value of 8 here is thousands. The place value of 6 here is tens. Okay, so it's very important you understand the difference between the place value of a digit and the value of that digit in a number. Is very important. Okay, so I'm quickly going to show us something, because I have noticed from experience, students find it very challenging, to name large numbers like this. Like if I tell you, okay, what is the name of this? You find a child saying something like 1,000,000, 3,000, 4,000, 8,000, It's challenging for students. So now here is what I always tell my students that helps them. Okay, I call this a 1,000 family. That always helps them to accurately name large numbers like this. Now, if you look at this part, you have 1, 2, 3. This is unit, this is tens, and this is 100. After the 100, what do you notice? You cross to 1,000. So you have 1,000, which is like units of 1,000. Then you have tens of thousands, tens, and then you have hundreds of thousands. So again, it's as if unit, tens, 100 is repeating here, and actually it is. And if you move on to million, you will find this is just a million, which is like unit of million. If we go further towards the left, the next one is supposed to be tens of million, and the next one hundreds of millions. So it keeps repeating. After every 3 positions, you change levels. After every 3 positions, you change level. Now, after unit tens, 100, which we call the ones family, we call this ones family, okay? Just know that it's one family because you call them singly, individually. But by the time you get into the family of 1,000, I call it the 1,000 family. Okay, why? Because this unit is 1,000, the tens here is 1,000, and the hundreds here is 1,000. And it's very convenient, to just call this the family, because the way we have in a normal family, these are the children in the family. If you are calling 3, if you are calling this number, you call this number as a whole entity, and then you call the family name. You call the number as an entity, and you call the family name. So let's see, for instance, how it works with this number 348. Okay, let's see how it works. That's the way I have shown my kids how to name these large numbers that I see has really worked, for a good number of them. So to name this number, what I tell my children to do is just isolate this number first. Okay, name it on its own, the way you would name it ordinarily if you find it anywhere. If you find this number like this, 348, what's the name? And at this level, they already know that this 348, this 3-digit number, is simply 348. 300, because this 3 is in the position of 100. 4 is in the position of tens, and unit 8 is in the position of unit. 8 units, 4 tens, and 300. 300, 4 tens, and 8 is 348. Fine. So now this number has been named, this 348, as 348. Then the next thing is call the family name. Call the family name. So you find the children are able to, okay, 348,000. Instead of them calling them singly like 3,000, 4,000. This helps them a lot. So you say 1,348,563. A lot easier. 1,348,563. Even when they are dealing with much larger numbers than this, where you have tens of millions, hundreds of millions, it's the same thing. So what you just do, for instance, if you have in the position of tens of millions, let's assume you have 6 there, and in the position of hundreds of millions, you have 8. Okay, so this TM, tens of millions, hundreds of millions. What do? This is 861 in the family of million. Remember, you have units million, tens million, and thousands and hundreds of million. So the 3 of them combine to form the family of million. So if you want to call this number 861, I tell my kids, how would you call this number if you see it isolated without being attached to any million or thousand? What's the name of this number, 861? They will tell you it's 861, because it's in the position of unit, tens, and hundred. So they will say 861, then call the family name. So you find it is 861,348,563. It makes it a lot easier, for them to pronounce. So looking at this number, since we have been able to name it using the positions each of the digits in the number occupies, we'll go ahead to write it in word form. The number again is 1,348,556. So now what we see here is the expanded form of this number. We have the 1 million, we have the 300,000, we don't have the 40,000, the 8,000, the 500, the 60, and 3. So what you see here is the expanded form. And also the expanded form also shows us the value of each of the digits. The expanded form also shows us the value of individual digits in this number. Okay, so lastly, what we look at here, and remember we said we're just trying to see the different ways we represent numbers. Okay, so here is one more way. Sorry, here it should be in words, not figure 1. So you have here 1,348,563. 1,348,563. So this is the written form of this number that we have here. And I'm going to show us one more thing. We have seen how the number is expanded. And please, before we move on, I would like to quickly mention that this form in which this number is written is called the standard form. When you write numbers the way we know numbers to be written as, okay, that is called standard form. Like if I write something like this, 256, this is standard form. Or I write 23,814, this is standard form. Okay, so if you hear representing numbers in standard form, this is simply what they're talking about. Okay, the way you have it here. Representing them in expanded form, this is what you have here. Representing numbers in written form, this is what you have here. Okay, so the next thing I'm going to show us quickly is how to change a number in expanded form to the standard form. Okay, we have seen how we can change a number in the standard form to the expanded form. We have explored that. Now I want to show us quickly how we can change a number in the expanded form to the standard form. Okay, so here we're going to quickly look at how we can convert a number in the expanded form to the standard form. Now, remember when we wrote our expanded form, we wrote it out in a horizontal way until we got to the last digit. Now, with that arrangement, you can also convert your number to a standard form. But if there is a number, a digit, or if there is a positional, a numerical position that has no digit in it, that is probably having a 0, if you're using that horizontal arrangement, you could easily make mistake. It's so easy to overlook the position where there is no value, there is no digit, that carries value. It's easy to just overlook that position, and then you now take the next number and put in its place. Except you have really mastered, this conversion. That is a very, very tricky part that a lot of people make mistakes on. So I always suggest to my students to use this method when they want to convert a number in the expanded form to the standard form. Why do I always suggest that? With this arrangement, you can never miss a thing. Now remember, we say when we are working with all these numbers, we always start from the side of units, okay? So when you are arranging your numbers, make sure you always arrange from the side of units. And once you do that, you will find out that your unit side will be a straight. There is not going to be anything missing on the unit side. It's just going to be straight down. So once you are able to follow this arrangement, you now finally add your numbers, you will get the correct number in the standard form. There is no missing this. There is no missing this. So what you do, just start arranging your numbers from the unit end, from the unit end, from the unit end. Because, for instance, this first number here has 6 zeros. It's a 7-digit number, right? Now, some people who haven't really gotten a hold of this concept when they want to write the next number, which is 300,000, they will probably not realize that, okay, this one has 1 0 less than this number. Okay, this one has 5 zeros, this one has 6. They could just go put the 3 under 1 and spread it out towards the right. It is wrong. You work from the right and spread your numbers towards the left. That's the only way you will miss it, because at the end of the day, there must be a number under your units. There must be number under your unit for every level. So the unit side has to be straight down, and you spread everything towards your left. Any number you are spreading to the left, wherever it ends, that's where it ends. Don't try to make it fit from the left hand. You always work from the right towards the left. So you see my arrangement. The right side is straight down, while the left hand is not, because the numbers do not have the same values. They end in different positions. So once you have gotten your arrangement like this, you go ahead and add. Okay, so add every digit has to be in its particular position. If you mess this up, if you scatter it or just write them anyhow, there's no way you arrive at the correct answer. So just look at them. So if you go down, these are zeros, only 3 is the number here that has value. So we have 3. So 0, 0, 0 plus 0 plus 0 plus 0, you have 3. 0 plus 0 plus 0 plus, only 6 is here, you have 6. 0 plus 0 plus 0, only 5, you have 5. Comma, 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 don't miss your comma. Remember, after every 3 digits, you apply your comma from when you're coming from the right towards the left. After every 3 digits, you apply your comma. Now 0 plus 0 plus 0 plus 8, that gives 8. 0 plus 0 plus 4, that gives 4. And 0 plus 3, that gives 3. You have another 3 digits, and we still have a number coming. 1 plus nothing, that is 1. There is your number. Okay, so if you look at this number, it comes back to where we started from. So this is just a case of if you are given an expanded number and you are asked to convert it to the standard form. Like I mentioned earlier, in the horizontal form where we first wrote out, the way we first wrote out our expanded number, we wrote 1 million plus 300,000 plus 40,000 plus 8, we wrote it out horizontally like that. You can use that to bring out your standard form. It's also a way of doing it. But why I chose to show this and encourage you to use this is, with this, you can't miss any point. But with the other horizontal one, it's so easy to overlook a position that doesn't have any value. Okay, where you have 0, it's so easy to overlook it, and then you push the next digit in the other position to where the 0 ought to be, and then you mess up everything. But if you take time to arrange it like this and then you add, there's no way you're going to miss it. Even when there's a position that has 0, it will be reflected and you won't miss a thing. So I always encourage you to use this method, when you are changing from expanded form to standard form. Now we're going to quickly look at how we compare numbers. Okay, now I'm bringing comparing numbers up here because you still find out that the knowledge of place value that you have is going to help you to be able to compare numbers and see which one is bigger and which one is smaller. Okay, so for instance, you have 2 numbers here, 28,149 and 28,098. We're going to try and compare these numbers. So what do? The knowledge of place value, with the knowledge of place value you have, you can just write out all the positions like this and then arrange the numbers under them. Now, in the case of comparing numbers, okay, always start from the left. That is the position that has the highest value. Please, when you are comparing comparing numbers, you do not start from the position with the least value, which is the unit. Most of the time we say we always work from the from the right towards the left. But in the case of comparing, you are working from the left towards the right because you are starting from the position with the highest value. You start from the position with the highest value and you work towards your right. So the position with the highest value here that we have is tens of thousands. And if we look at the 2 numbers, they have equal value. So you can't decide. You move to the next one, which is 1,000. In the position of 1,000, they also have the same numbers, the same digits. So you can't decide. Next, we go to the next position, which is 100. In hundreds, you find that one has the digit 1, the other has the digit 0. And we know that 1 is larger than 0. We come to the end of our search or exploration. You are going no further. So you have found 1 is bigger here in the position of 100 than the other. So that simply means that this first number, that is 28,149, is bigger than 28,098. Now that brings us to an interesting point. How do we write is bigger in numeracy or in mathematics? There are symbols that we use to show when a number is bigger than the other or smaller than the other. Okay? I always tell the kids, in fact, it's a common way of telling students how to remember these signs. We use the greedy crocodile, which goes like that. And we tell the kids that the greedy crocodile always goes for the larger number. The greedy crocodile always goes for the larger number. So the mouth of the crocodile, if you look at this symbol, it looks like a crocodile that his mouth is opened. The mouth of the crocodile is always opened in the direction of the bigger number, and it closes up in the position of the smaller number. So if you are using this, you make sure the open end faces your bigger number. Okay? It faces your bigger number. So here, since we have concluded that 28,149 is bigger than 28,098, that means the crocodile mouth faces this number, the first number, because we have decided that this first number is bigger than the second one. So the crocodile faces the bigger number. Now, if you write your smaller number first, for instance, if we write, let's see, maybe I'll write it here. If we write 28,098 before we write 28,149, that means the crocodile mouth will be facing towards the right. This is how it will be written. Why? Because I have written the smaller number first, so we use the second symbol. Okay, but if we write the larger number first, the symbol goes this way because the mouth of the crocodile is always open towards the larger number. And then this third sign we have here is the sign of equal to. Okay, so you use that for two numbers that are exactly the same. We're going to continue exploring all this, but I just wanted to use this opportunity, to introduce you to this and also link it with our exploration of place value, because at the end of the day, you find out that your understanding of place value is going to help you to just take care of every other thing that is left in this number exploration. I hope we have learned something in this lesson. Please, you need to go over this video again. Because this is a kind of foundation that is laid in really getting or having a deep understanding of numbers and how number works. Okay. We hope to see you again next week. If you find this video helpful, please help us share the link and spread the word out there. See you next week. Stay blessed and stay safe.